Okay, we're doing lesson 8, day 2, some more of sector and segment areas. We'll do some application problems today. So talking about the same concepts as yesterday. But we need to include some old stuff that we learned about circles and polygons. So let's do a little review. The diagonals of a square are congruent and perpendicular. They also bisect each other, and you can see that in this picture down here. They're purple, they're perpendicular, they're congruent, they bisect each other, and they also bisect the angles. Okay, a rectangle has 4 congruent 90-degree angles and congruent opposite sides. And we can check the drawing to confirm that. The diagonal of a square, so one of these here, creates 2 congruent special right triangles. The 2 congruent right triangles are both 45, 45, 90 triangles, or isosceles right triangles. We talked about those yesterday. And then something from earlier on in this unit, a diameter of a circle that is perpendicular to a chord of a circle is also the bisector of that chord and the associated arc. So again, we're going to have a bunch of composite shapes today. Here we have a square inscribed or inside a circle. The length of each side of the square is 2 centimeters. Determine the area of the shaded region. Right, step 1 is always to put on the diagram the information that we know. So we label each one of these sides with 2 centimeters. And then I go up here and I get that diagonals with the perpendicular there. I'm thinking that might have helped me there. Okay, so the solution. There's a couple of ways to tackle this problem. One way is to find the area of all 4 segments individually and add them together. We learned the formula for doing that and hopefully practiced that last night in the homework. And it's even easier than that. Since all segments are congruent, it is only necessary to calculate, I should say, 1 segment area and then multiply it by 4. So if that's the approach you'd like to use, go right ahead. I'm going to suggest another approach. And this one comes in handy a lot, where we can find the area of the circle and then subtract the area of the square to get the area of the leftover segments, which is what we're interested in. So how can we do this? Finding the area of the square seems pretty easy. That's 4 centimeters squared. How about the area of a circle? Well, we need the radius for that. So I'm going to use the fact that I have these 2 diagonals. They are chords of the circle because they go from on the circle to on the circle, but they are perpendicular to each other. So I know these are both diameters. So all I have to do is figure out what one of these little segments would be, and then I have my radius. So I go back to this here. I have 2, 2, and this would be 2 square root 2, and we should remember that from yesterday. And then we would divide this diameter in half to get the radius. So the radius is square root of 2. So now we can calculate both the area of the circle, so that's square root of 2 squared pi centimeters squared, and the area of the square is 2 squared centimeters squared, and we would subtract the 2. I'm going to simplify that also. So I have 2 pi minus 4 centimeters squared. That's the exact value. If we were to use 3.14 as an estimate for pi or the pi key, we would have the estimated shaded area. This one's fairly scaffolded. We'll go through this one together and maybe one of the circle problems, and then you could do the other couple on your own. All right, so what we want to do here is to use our estimate for pi, and we're going to round to the nearest tenth. So the first thing is to identify the different shapes. So shape 1 I see is square. Shape 2, let's see, well, if that's a 90-degree angle, then that one must be 90. I'm going to say this looks like it's a fourth of a circle, because it's 90 out of 360, which again from yesterday we may remember is just 1/4. And then, oh, I guess I'm going to use that one here, sectors, right, 1/4 of a circle. And then the third one would be a rectangle. And then if we put in the formula for each of these, this would be side squared, length times width, and this would be 1/4 radius squared times pi. And now we just need to substitute in the values here and add them all together. So our square is going to be 3.5 squared, and our rectangle is 7 times 3.5, and then our sector is 1/4. What's the radius? Well, if this is a square, those have to be congruent. So 3.5 squared times pi. We use 3.14 for pi to get our answer. We'll go ahead and get our calculator. I'm going to do one more thing here. I have 4/4 and 1/4, so I really have 5/4 of a 3.5 squared. And a 7 times a 3.5. No, wait, I don't think I'm going to do that because that one's attached to a pi. Never mind. I'm going to do 3.5 squared and 7 times 3.5 and 1/4 of a 3.5 squared times 3.14, because that's where the directions choose up. And then we need to grab our calculator and put that in there. If you have the nice TI-84, you can put that in all at once. We get 46.366, blah, blah, blah. We're going to round to the tenths place, so 46.4 feet squared. Again, it's the area, so we're using units squared. The one below talks about finding the shaded region, so we want this yellow part here. So again, we have two options. One is we could find the total area, and subtract off the unshaded portion. Or we could just find the area of the shaded portion. So you decide which one you think makes more sense to you, to understand. Maybe I'll just do the area of the shaded portion. Okay, since this is 109, this central angle is 109. This is the diameter. So this is 180 minus 109, which is 71. So what I have here is two 71s out of 360. Okay, there's my fraction, but I have two of them. So you could write that as 142 over 360. And then my radius squared times pi. And then I'm going to use 3.14 for pi. And now that I have everything calculated, I'm going to get my, or written out, I'm going to get my calculator. We don't want to get our calculator until we have everything written out, ready to put in the calculator. And we get 33.49, so we round that to 33.5 feet squared. All right. So you can go ahead and try these other two. Again, you can use these bottom two are perimeter, so this is old stuff. We've already done that, perimeter. This one you can use the same strategy. I think I would use the total area, subtract the unshaded to get the shaded. So I think I would use, for that one there, this one above it. And then your last little assignment is to go ahead and complete this exit slip.